Hi everyone, and welcome to our OECA series course on SSH management and security. I'm Irene, and I'm really excited to guide you through everything you need to know about setting up, securing, and managing your SSH services. In today's course, we are going to dive deep into SSH, which stands for Secure Shell. It's a super reliable and secure protocol designed for remote logging sessions and other network services. Think of it as your secure gateway for managing remote systems, helping you prevent information leakage during those crucial remote administration tasks. Originally, SSH was a program on Unix systems, but it quickly became popular across pretty much every operating system out there. When used correctly, SSH is a fantastic tool for patching up potential vulnerabilities in your network. Plus, SSH clients are available for tons of platforms, from HP Unix, Linux, AIX, and Solaris to Digital Unix, IRIX, and many more. By the end of this course, you will be able to set up and securely configure an SSH service on an openEuler system. Connect to an SSH server using an SSH client. And finally, perform routine SSH operations and troubleshoot common issues. So ready to get started? Let's jump in. Alright, so the first step is getting your SSH service up and running is understanding the software packages involved. You will typically need at least 3 core suites: openSSH, openSSH server, and openSSH clients. Let's break them down. OpenSSH. This suite provides the prime numbers used for interactive algorithms found in extra SSH moduli. It also gives us handy tools like a user being SSH keygen, which is essential for generating your host authentication public and private keys. OpenSSH server. It contains the main program for your SSH server, SSHD, located at user sbin SSHD. You will also find its daemon configuration here. User live systemd system SSHD service, and the crucial SSH server configuration file, extra SSH SSHD config. OpenSSH clients. Finally, if your openEuler system is acting as an SSH client, this provides all the necessary command line tools like /user/bin/scp, /user/bin/sftp, and /user/bin/ssh. It also includes the SSH client configuration file at extra SSH SSH config. Now, good news. openEuler usually includes these suites by default, but if for some reason they are missing from your environment, no worries. You can always refer back to our previous tutorials on DNF management suite to get them installed. You can also use the RPM command to quickly check which SSH-related suites are already installed on your system, and even see a list of the files each suite contains. Pretty neat, right? Now that we know how to set up the service, let's talk about something super important: security. All your SSH configuration files live in the /extra/SSH directory, and the primary one for your SSH server is SSHD config. We are going to go through some key security parameters you will find in there. Just a quick note. When you see default value mentioned, it means that if you don't explicitly configure that parameter, the program will use the setting by default. Here are some important ones. Port. This sets the listening port for your SSH service. The industry standard is port 22, but honestly, this makes it a prime target for attackers. It's a really good idea to change this based on your network supporting planning. Listen address. By default, this listens on all network interfaces. While convenient, it expands your attack surface. You should definitely configure a specific listening address based on your needs. I highly recommend configuring it to only listen on your management IP address. Permit root logging. This controls whether the root user can log in remotely. The default is prohibit password. Setting this to no is strongly recommended. If an attacker gets the root password, they can't just log in remotely. So disabling remote root logging significantly reduces your attack surface. Permit empty passwords. This one is pretty straightforward. The default is no, and you absolutely should never set it to yes. This prevents users with empty passwords from logging in, which is a huge security risk. Use PAM. This controls the use of PAM, pluggable authentication modules policies. The default is no. PAM offers more robust user authentication and management features, like limiting login attempts and locking or unlocking users. While SSHD configs max auth tries only limits login attempts, PAM goes further, helping to protect against brute force attacks. So you should configure this field to yes. Syslog facility. This defines the system log facility, defaulting to auth. This setting determines how your SSH logs are categorized by rsyslog service. In extra rsyslog config, you will find the rule authpriv.*var/log/secure, specifically for security logs. I recommend setting syslog facility to authpriv. This ensures that your SSH service logs, like user authentication events, login, and logout records, are properly recorded, providing valuable support for security incident analysis. Ignore rhosts. This defaults to yes. The rhosts configuration used in the insecure rlogging protocol grants remote access. Since the rlogging protocol is no longer secure, you should definitely prohibit the use of rhosts configurations. So keeping this set to yes is a good call. One crucial thing to remember: whenever you modify the SSH service configuration file, /extra/ssh/sshd config, you will need to restart the SSHD service for your changes to take effect. We'll cover the specific commands for managing the SSH service in the next section. And here's a pro tip. You can use the command sshd-t to check if there are any errors in your current /extra/ssh/sshd configuration. Always a good idea to do that after making changes. Managing your SSH service efficiently is key. You will want to ensure it starts automatically when your system boots up, and you will often need to restart it after making configuration changes. Here are essential commands you will see. To set the SSH service to start automatically on boot, use system control enable sshd.service. To set the SSH service to not start automatically on boot, use system control disable sshd.service. To check if the SSH service is enabled for auto start, use system control is-enabled sshd.service. If you see enabled, it means SSH is set to auto start. To start the SSH service, use system control start sshd.service. To stop the SSH service, use system control stop sshd.service. To check if the SSH service is currently running, use system control is-active sshd.service. If it shows active, your SSH service is up and running. And finally, to view detailed information about the SSH service operation, use system control status sshd.service. This command gives you a comprehensive overview, including its daemon configuration, current status, how long it's been running, the main process ID, any child process IDs, and more. Super helpful for troubleshooting. Now let's switch to SSH client configuration. This is what you will use when connecting to an SSH server. It's important to understand the order in which SSH client parameters take precedence. Command line parameters, then configuration file, then parameters, and last default values. Let's use a port as an example. First, the client checks if a port is specified directly in the command. If it is, that's the port it uses. If not, it then checks if a port is configured in the SSH client configuration file. If found, it uses that. If neither of those is present, it falls back to the default port, which is 22. Regarding configuration files, the order of precedence is configuration file, specified by the -f command line option, and then the SSH config file, and then the extra SSH and SSH config file. A quick note here. When you say check if the configuration file has a parameter configured, it only checks the selected configuration file, not every single one. Let's look at some key parameters you will find in these client configuration files. Port. This is the destination port for your connection, defaulting to 22. If your SSH client doesn't specify a port when connecting to an SSH server, it will use this configured port. Strict host key checking. This parameter controls how strictly your client verifies the host key of the server you are connecting to. The default is ASK, which is recommended. The client will prompt you to accept the host authentication key if it's a new host. Only after you confirm will it add the key to SSH known hosts. This is the safest approach, as it warns you about potential man-in-the-middle attacks. If you set this to no, the client will automatically add the server's host authentication key to the SSH known hosts file without any prompt, even if it's a new host. So generally not recommended for security. If you set it to yes, the connection will be refused if the server's host key isn't already in your known hosts file. Alright, let's talk about the tools of SSH client. First, user bin SSH. This is your go-to command for remote logins. The basic syntax looks like this: SSH space option destination space command and arguments. A quick tip: if you don't specify a user in a destination, the client will try to connect using your current local username. Here are some important parameters you will often use with this tool. -p, lowercase. This is super important. Use this to specify the destination port for your connection. This port number must match the port your SSH server is listening on. If your SSH client's default or configured port isn't the server's listening port, you will need to use the -p to ensure a correct connection. This option will override any port settings in your configuration files. -f. Use this to specify a custom configuration file, overriding the default ones. -e. This is a great debugging tool. It appends debug logs to a specified log file instead of a standard error. It doesn't affect standard output, so it's perfect for troubleshooting connection issues without cluttering your main terminal. -v. This enables verbose mode. It makes the program print debug messages about its progress. This is incredibly helpful for diagnosing connection authentication and configuration problems. You can even use multiple -v options, up to 3, to increase the verbosity and get even more detailed output. Here's an example of what it looks like the first time you remotely log into a new host with SSH. And this shows how you can use SSH to execute a command directly on a remote host, like checking the contents of a file. Next up, we have /user/bin/scp, which stands for secure copy. This is your go-to tool for copying files between hosts in a non-interactive way. Think of it like a secure version of the cp command for remote machines. The basic syntax is scp space option space user at host 1 file 1 space user at host 2 file 2. Again, if you don't specify a user, scp will use your current local username for the connection. Here are some important parameters for scp. -p. This is crucial for scp. It specifies the target port for your connection. Just like with SSH, this port number must match the SSH server's listening port. If your client's default or configured port isn't the server's listening port, you will need to use -p to connect correctly. This option will also override any port settings in your configuration files. -F, just like with SSH, use this to specify a custom configuration file. -V enables verbose mode for SCP as well, useful for debugging file transfer issues. You can use it multiple times for increased verbosity. Here's an example demonstrating how to use SCP to copy a file from your local machine to a remote host, renaming it in the process, and then verifying the transfer using SSH. One important detail to remember: SCP space uses the -uppercase P to specify the port, while SSH uses the -lowercase p. Don't mix them up. Finally, let's talk about user bin SFTP, which is the secure file transfer program. This tool is commonly used for interactive file transfers, giving you a more FTP-like experience, but securely over SSH. The basic syntax is SFTP space option space destination. And as with SSH and SCP, if you don't specify a user in the destination, SFTP will use your current local username. Here are some important parameters for SFTP. -uppercase P, like SCP, SFTP uses a -uppercase P to specify the destination port for your connection. This port number must match the SSH server's listening port. Use it if your client's default or configured port doesn't match the server's. This option also overrides configuration file port settings. -F, use this to specify a custom configuration file. -V enables verbose mode for SFTP, great for debugging interactive file transfer issues. This example illustrates how you can use the SFTP client tool to both upload files like hello.txt and world.txt to a remote host and download a file like hello-world.txt from the remote host to your local machine. During your SSH journey, you might encounter some connection issues. Don't worry, these are common, and most have straightforward solutions. Here are some common errors and how to tackle them. The first kind of error is connection refused. This means the server actively rejected your connection attempt. The symptom is that the SSH server service is down or behaving abnormally. The solution is to check the SSH server's service status. If it's not running, start it up. Or your SSH client is trying to connect to a different port than the SSH server is listening on. So when executing your SSH client command, make sure you specify the correct target port number. Remember, the -lowercase p for SSH and the -uppercase P for SCP and SFTP. Or maybe the network interface your SSH client is different from the network address the SSH server is configured to listening on. In this case, adjust the SSH service listening address to include the network interface your client is using. The second kind of error is too many authentication failures. This means you've exceeded the allowed number of incorrect password attempts. Maybe you've entered the wrong password too many times, or perhaps the wrong username. So double-check your username and password and try logging in again with the correct credentials. Or on the SSH server, the user account you are trying to use might be restricted. For example, their shell could be set to /sbin/no-login or /bin/false, or the user might be locked. If the user's shell is set to prevent logins, you will need to modify the shell attribute. This depends on your business design. If the user is locked, you will need to unlock the account before they can log in. The cause could also be that on the SSH server, the SSHD config file might have block lists or trust lists that are preventing your user from logging in. In this case, configure the user to be within the allowed trust list range on the SSH server and ensure they are not restricted by any block lists. The third kind of error is remote host identification has changed. This is a security warning indicating that the SSH server's host authentication key has changed since the last time you connected to it. This can happen legitimately. For example, the server was reinstalled, or maliciously. For example, a man-in-middle attack. The solution is On the SSH client, you will see a clear message telling you which line in your SSH known host file needs to be removed. Just follow the prompt. Delete that specific host key record from your SSH known host file, and you should be good to go. If you are concerned about a malicious attack, investigate further before reconnecting. Well, that brings us to the end of our course on SSH management and security. I hope you found this information helpful and feel more confident in setting up, securing, and managing your SSH services. Remember, SSH is a powerful tool, and understanding its ins and outs is crucial for secure remote administration. If you have any questions, feel free to review our course materials or reach out. Thanks for joining me, and happy secure remote computing!